So welcome to lesson 2, where we will be covering variables and data types for the Python programming course. So previously we looked at using CoCalc and the Python interpreter just to do some basic calculations and playing around with variables using a Python interface or interpreter. But ultimately, this is not the way to use Python. We need to be creating files and running those files. So to do that, we need a proper piece of software, also known as an IDE or integrated development environment that can, allow you to code and run Python files. Very similar to MATLAB. I have done a lesson on this called Appendix Spider Setup. So I'll suggest you first do that before you carry on with this lesson, which shows you how to install the software called Spider, which will allow you to run Python code. There are other IDEs or software you can use to run Spider, like PyCharm, VS Code, Sublime, also Jupyter notebooks as well. But Spider, I just found for data science specifically, is very useful and easy to use. So that's why I definitely recommend it. All right, so if you've installed the Spider, then you can follow this lesson a bit better. So we're first going to go through the interpreter, which in Spider is called console. So if I'm going to open up my my Spider, we can just do a few examples just to show you that the interpreter or console still exists in Spider as well. So here we have, I did examples earlier, but I can do it again. I can say like, x is equal to 10, y is equal to 20, sum 2 is equal to x plus y, and you can print sum 2. Right, so it's a very simple, straightforward stuff you've done before in the first lesson, and you can see very useful. This is Variable Explorer. You can see all your stored variables as they change. Okay, but the second way and the most important way is how to actually create a Python file, right? And we'll show you that over here. So on your top left, you'll see a section to write Python files. So to do that, I can do the same things. Maybe call it like, I can call A equals 5 and B equals 20. My sum equals A plus B. I then print my sum. Right, and then I'm going to save the file, save it over there, and then you can rename it or whatever you want. If you name it to something applicable. Then for Windows, press F5 or the green button. And then you get the output in the console. So the console acts as an interpreter to interact with it, you can write code, and shows output of your files. All right, so in terms of the variables, we can look at various types of variables now. So we've done two types, which is integer and a string, but there's one more, which is quite important, which is float. And float is a variable number that has decimals in it. All right, so first let's check what type of variable, for example, x is if it's equal to 4. So I'm just going to copy and paste this over here. I can copy and paste it as is, go to my file, and maybe just paste it here. You can also type it out if you want. And I'm going to save, Control S, run it, and you'll see that I can actually comment this out here as I don't print that anymore. To put a comment, you just put a hash. The shortcut key in Spider is if you press Control and the backslash key. It's a shortcut just to make something comment or uncommented. So save that, run it again. It just shows me that this is integer type variable. Let's say like a 0.2, for example. Let's see what happens. It's a float, right? Because it's a floating number, it is decimal. if I put apostrophes over here, it should be a string, str for string. Right, so these are the three main data types that you're going to be working with. All right. So these are the examples that I showed you. So again, in this case, I wanted to use the print function. It would look like this. This is if I want to store a variable string, right? So this is actually going to give me an error, and if you can figure out what that is, that'll be useful. It says CHPC is not defined, and that is because CHPC it thinks it's a variable, right? So, but it's not a variable; it's a string, it's a word. So actually, you have to put double quotes and then run it, and then I'll print that CHPC over there. So similarly, again, if you maybe want to print text with the variable, I can do that as well. So just copy that, and I think yes, it'll be in one line because it will give you error. Maybe just make this all into one line. So I want to add this variable to the string over here. So if I just do maybe, if I just want to print this text, very similar to the echo statement. Print and echo is quite similar. I run that to say I'm doing a course. But let's say if I want to add, like, I can say course over there. If I save and run it, I'm doing course high performance computing. Okay, so you can also do the same with numbers. So let's see what happens if we do that. I see we get an error here. So let's see if I'll get an error. Let's just make it one line, and let's try and run it. It says cannot concatenate strings because course here is actually a integer type, right? If we actually just check now what type of variable course here is, just by saying type. Then we'll see that it's integer. Let's rather make it a string. So to do that, we can say course here equals, and then we just say str. Course here, let's check out the type again and see if it changed. Save and run it. There we go. So we changed it to a string, and now it can properly print that out. Okay, so that was a problem for that one. So this is quite important if we want to cast it. If we want to change between variable types, we call it casting, the cast between integer, float, and string. All right, so let's go through the data set we had before, just to do some practical. Now in this data set, we had, you can see cell B2, B3, B4, we had all these values. So we can also do the same in Python. We can say maybe like B1 equals 30, B2 equals 40, B3 equals like 50, or whatever it is, right? But it's a bit tedious to be able to print all these values out, but let's just try it in case. So I can say print B1, and I should see value 30, right? So that's a value that I'm getting at. Very cool. I can see its values in the variable explorer too. All right, so let's go back. There's two notes. All right, so, but as I said again, it becomes a bit tedious if you have to create a new variable for each value. So what you're going to do is use another data type called a list. And a list can store multiple variables using square brackets. All right, so how are we going to do that? So let's go back here, spider. So I'm going to call variable put age and say equals, and I'm going to use square brackets. Inside the square brackets, I'm going to say 30, 40, 50, 10, 20, right? And this actually stores all these values inside an age list. Okay, so let's now print age and see what you get. Save it, all these values over there, which is a lot better than trying to create a new variable each time. Okay, so very importantly, we can access certain values by using indexing. So what do you mean by indexing? Right? So let's first do a few examples. So we can say if we want to first access the first one, the first index is actually 0. So I'll print and run that. We see it's 30. So 1 is actually the second value, and 2 should be the third value. Like that. So how is it happening? Let's have a look. We can store all these values of age in the list called age, right? So take note that to access any of these values, we need to access it using the index. So where index refers to the location in the list data type. So if we have these values like 30, 40, 30, 49, whatever, the first index is the first value, so that's 0, then it's 1, then 2, then 3, right? So the first value is actually not, we don't use 1. First value, or the first position is actually starts at 0. Starts at 0, not 1, right? So that's why we saw an error here. We tried to print, there's only age 11 actually refers to is actually out of range, and because it's actually 11 values, and 11 here actually refers to the 12th one. All right, so what are the cool things we can see here? Okay, with Python, we have built-in functions because you want to do what you've done before in Excel by working with the minimum, maximum, average, standard deviation. You can actually have built-in functions for this, which is quite cool. So to work that out, for example, let's print out the minimum of age. We can do that. So that's going to be 10. We can do a maximum 50. All right. Now to work at the average, we need to find the length. So let's say length of age is going to be the length of age, and then we also need to find the sum of age. Please note how I'm creating these variables. I'm using an underscore in describing. The first word is descriptive. The second one is what I'm describing. So sum of age. Okay, and then the average would be obviously the sum of age divided by the length of age. Right, so print average. You should get that out. Okay, so I can actually comment all this out by just saying control. And, sorry, it's actually my mistake. I should control 1. Right, so to comment and uncomment is actually control +1. That will comment or uncomment everything. All right, so let's save and run that. So, okay, it's a good mistake. Haven't defined it yet. Age, age, okay, there you go. That's 1 I still need. There you go. So 30. That's average for all of those. Those are pretty cool. You can find all these metrics that we got in Excel quite quickly. All right, so if you do the same thing with the gender column as well, but just note this gave an error because it doesn't have the quotes here, double quotes. And we can do the same thing over here. So I'm just going to copy and paste this as is. It should just work. Just copy that and just make it a 1 line. And it should get MM. Yeah, there we go. And then, yeah, so again, I think we've done this before, but -1 just refers to the last value. So this is known as negative indexing. Importantly, dates as well. You'll be using dates quite a lot, especially with the data you might be using. So just for now, I'd suggest just using strings to work that out. So data types, there are different types of data types called a dictionary and tuples and sets, which store also multiple values, but we won't be covering that just yet. Yeah, so this last part just shows more examples of casting, how to convert between different data types. And this is the end of this lesson. Thank you.